we're dropping an object, let's say from a plane. Okay, so we're dropping an object. The object will have free fall. Free fall, that means assume there are no winds or anything. Then we want to determine the distance the object travels. And the distance the object travels is basically something related to the gravity, right? So let's suppose that the distance will be 16 multiplied by t square, where t is the time travel. Okay? So we want to see if we have, let's call this one, for example, t0. Okay? We want to know, for example, at t1, which is a time after t0. So let's call t1 equals to t0 plus h. We want to know what is the distance at time t0 plus h. Okay? And then if we subtracted the distance at time t0 plus h minus the distance at time t0, what will it give us? Huh? Shabab, think about it this way. This is Dammam right here. This is Riyadh right here. Okay? And let's say this is the border of Saudi. Assume that you have a road. The road is going this way to Dammam, and then it keeps going all the way until it gets to Riyadh, for example, and then maybe it will keep going until it goes to Jeddah. Let's say Jeddah. So if I subtract it, okay, the mile for Riyadh, let's suppose that you use kilometers. Let's suppose that Dammam, if we started from let's say the gateway to Bahrain, if we started until Dammam, let's say it's like 10 kilometers or less, let's say 10 kilometers. So this is kilometer 10. So you travel from kilometer 10 until, for example, kilometer 410 or 400. Okay, so if you want the distance, you subtract this kilometer from this kilometer, right? If you want, you subtract these two. So we assume that we have an object that is having a free falling. It is distance is given by this 16 times t squared. So we said we want to subtract the distance from time t to the time t0. If we do so, then that means time t1 equal to t0 plus h, correct?
Yes.
Good. So if we want to get the distance, then we will say it's equal to what? 16 times t1 square minus 16 times t0, okay? And if we want the velocity, we do what? We subtract by the time we travel this distance, right? The time we traveled this distance, we started at t0, we ended at t1, and since t1 is equal to t0 plus h, then we can just subtract. The distance traveled will be what? t1 minus t0. So if we get t0 from here, t1 minus t0 will give us what? Th, right?
Yes.
Everybody? I'm just going to write it over here for you. So we have 16 t0 square or t1, 16 t1, sorry, 16 t1 square minus 16 t0 square divided by t1 minus t0. Okay, this is equal to this, right? All we did is we plugged in, instead of t1 minus t0, we plugged in h. Okay, so you can have 16 t square, t1 square minus 16 t0 over h, right? This we can go ahead and say this is equal to 16, okay? And I'm going to put here t0 plus h all square. Okay, did I change anything? I just put back what is T1.
No.
T1 is 0 plus h, so I put T0 plus h squared, right? I'm going to subtract from this one what? 16 T0 square, okay? Because this is also square, sorry. Right? And then we're going to divide it by what? Divided by what? Divided by h.
By h.
Okay? If we do the math, we're going to get something like this. 16 T0 square, and then we will have what? Plus 32, somebody help, 32 T0, h, correct? Everybody? Plus
Yes. T0 square.
16 h square, correct? 0 square.
Correct.
Everybody see that? And then minus 16 T0,
T.
correct?
Right.
And this is divided by h.
H.
We can cancel this one, right? With this one, correct?
Correct.
So what are we going to be left with? 32 T0 square h, right? So we'll be left with 32 T0 square h minus or plus 16, right? 16 h square, right?
Right.
Over h. So if we divide by h, what are we going to get? We're going to get what? 32 T0
T0 square
square
plus 16h.
Thus.
16h, right?
Right.
Now, this is the equation that we can use to give us what? To give us the distance traveled. If we divide it by h, we already divided by h, so that's going to give us the velocity. Okay? So anybody not able to follow the development from the beginning to end? Everybody is comfortable with it? Okay.
Yes.
Good, good. If that is the case, then we're going to go back to our regular work. Okay, so we're going to go ahead and get to this. Okay, so do you see the new screen?
Yes.
Okay, good. So let's just do this one. Okay, so when f of t measures the distance traveled at time t, the average speed over the period from T1 to T2, where T2 is when you stopped, T1 where you started, okay, is equal to the distance traveled divided by the elapsed time, the time it took you to go from point A to point B, okay? And that's equal to what? F of T2 minus F of T1. Remember, we said what? We said f of t2, f of t measures what? The distance traveled at time t. So f of t2, that means the distance when you reach your destination. Minus f of t1, the distance when you started. Remember when I talked about Riyadh and Dammam? Remember? So
Yes.
we subtract the mile for Riyadh, it will be like mile 400. From a mile for Dammam, maybe like mile 10 or
10.
kilometer 10. And then when you divide this by the time, it will give you what? The average velocity, because the distance divided by time will give you average velocity, right? This is average velocity. Okay? Is everybody comfortable?
Yes, yes.
Good, good, very good. Now
it's
let's...
like physics.
Yeah,
It's
Question?
like physics. No.
Okay, good. Let's take a look at this equation. This is the same equation as the one that I just went through at the beginning, right? The only thing is, this is called delta y. That means the difference between y where we stopped and y where we begin. And this divided by delta t is difference between the time when we started at y and the time when we ended, right? So let's take, for example, h equals to 1. If we take h equal to 1 and plug it in over here, we get what? We get t0 plus 1. So let's take t0 equal to 1 also. If we take t0 equal to 1, we will have 1 here plus 1, that is 2. 2 square will give us what? 4. 4 times 16 will give us what? 4 times 16 will give us 64, right?
Yes.
Correct? Minus 16 times t0. T0 is equal to what? 1, right?
1.
16 times
Right.
0 is 16, right? And this is divided by h. What is h we're taking now? H what is 1, right? So this is going to give us what? 48, right? Do the math. Do the math. 48, right? 64 minus
Yes, yes.
by 1, 48. Okay? So that means the distance is like the average speed, sorry, is 48, right? Now, let's use for h point 0. If we use for h point 0, I'm just going to do this one and then you can get the idea. So for h point 1, if we use point 1, then the equation, I'm going to have to write it over here. It will be 16, right? And then we have parentheses t0. T0 doesn't change, equal to what? T0. Shabab, T0, what is it equal to?
1.
Just follow this. So it will be 1 plus h now has changed because we're going to use h what? 0.0. 1, right? 0.1. So this is plus 0.1, right? All what? Square minus 16
16.
Times what? T0
1 square.
square is 1, so just like minus 16 divided by divided by what? By
0.1.
0.1. If you do the math, you have what? 1.1, right? 1.1. 1.1 square is equal to what? 1.21, right? So you do 16 times 1.21, okay, minus 16 over 0.1, and that will give you 33.6, okay?
3 points.
Yeah, 33.6. And if you do the math, you'll get the same answers, okay? If you just keep going, what's happening to h? H is what? We're getting it smaller, smaller, and smaller, and smaller, right? Everybody see that we're getting h smaller and smaller?
Yes.
Yes.
H smaller and smaller, what happens to average speed? Average speed is getting smaller, smaller, right? Until when we put h like 0.0001, the average speed is like 33.0016, correct? This is for t 0 equal to 1. But we don't have to use t0 equal to 1. We could use t0 equal to 2, right? If we do t0 equal to 2, these are the numbers. You can check them yourself. They will be okay, right? So in the end, when we took h smaller and smaller until we reach this point, you can see for this column, we have what? reach 32.00h. Okay. Now, let me ask you this question. What if I have the same equation? Let's say here, the equation is what? The equation is 16, okay, T0 square plus H, sorry, this is a square. This is a square, there's no square here, okay? So 16 T0 plus H, okay? T0 plus H square minus 16 T0 divided by H, okay? This one, if we spread it out, remember when we did it at the beginning, if we spread it out, we'll get what? 16, T0
Square.
square,
Yes.
T0 square,
Mhm.
plus
Plus 16h
32,
32.
T0 H,
H.
right? And then,
Minus
how about plus
or
16
plus, yeah.
H square? And then minus 16 T0
T.
square, right? This is T0 square. This is square. Everybody see that? Shabab, everybody see what?
Yes.
Okay. So this is, oops, God, that's stupid. It just took it out. Okay, so let me write it again. Just bear with me, please. The system sometimes is very unfriendly. Okay, so we said what we had is we had 16 T0 square, if we just took the bracket, plus 32 T0 H plus 16 H, sorry, H square, right? Minus 16 T0 square, right? Everybody?
yes.
Yes.
Everybody? So we have what? 16 T0 square. It goes with what? 16 T0 square. And we're
16 square
dividing this one by what? By
by
H, right?
H.
Now, then
Yes.
this square is gone, so we still have what? One H here, right? Because this was 16H square. We're dividing by H.
Yes.
So this H is eliminated, this H is eliminated, right? Everybody?
Yes.
Yes, Doctor.
Now, what if I
Still
so
32
let us set H equals to 0. What are you going to get?
32
Excellent, 32, correct?
T0.
Everybody see that?
Yes.
Okay,
Yes.
you can see that we're dwindling H. That means we're taking it smaller, smaller, smaller. When H goes to 0, this value goes to 32. Okay? Is everybody convinced?
This is only when t is equal to 1, t0, right?
Yeah, it could be T0 equal to 2, but then the result will be 62. 2 is just twice this, right? 2 is just twice this. So it will be 32, this will be 64. If it is 3, it will be 3 times this. If it is 4, it will be 4 times this. The relation is linear. Okay?
I see.
Okay? Everybody? Everybody is confident?
Yes.
Very good.
Yes. That's okay.
Good. So let's get going. Let me get the pointer. Now, the average rate of change of y equal to f of x with respect to x over the interval x1 comma x2. We can say it is delta y divided by delta x, which is equal to f of x2 minus f of x1 divided by x2 minus x1. This is similar to what we just talked about, but now we put it in terms of what? The context of the calculus, which is x1 and x2 and all of it. Okay? So this we can write equals to what? F of x1 plus h. That means what? x2 is equal to what? x1 plus h, right? So f of x1 plus h minus f of x1 divided by h. This is the same as the that we just argued, right? Assuming h is not equal to 0, because you don't divide by 0. Okay? Everybody is following this rate of change?
Yes.
It may look weird. It may look a little bit strange, and it may look difficult to remember, but once we go like 2 or 3 problems, you will remember this right away. Okay? Any question? If there are no questions,
Clear.
we're going to go ahead and continue. Okay. Now, remember we talked about the secant last time?
Yes.
Everybody remember that? Let me just move this one up. Everybody remember when we talked about the secant last time?
Yes.
Okay.
Yes.
What did we say about the secant? Why do we need to even draw the secant? Why do we need to draw this line? The secant. Why do we need to draw this line? Huh?
We want to find the rate of change, and we choose.
Excellent. We want to find the rate of change of what? Rate of change on this curve, right? If we move from x1 to x2 using this curve. So we're moving what? We're moving this curve, using this curve until we get to x2. We're talking about the horizontal distance, not the vertical. So we reach x2 over here, right? So what is the rate of change of, let's say, distance with time? We cannot find the rate of change from what? From a curve. So what do we do? Because we want the rate of change between 2 points, then we have to connect these 2 points. Remember when we did the height of the growth of a toddler, right? A human being, the growth. You remember, right?
Right.
The slope of this secant is the same as what? The rate of change from x1 to x2 for the curve. Okay? So you can see that x1 and x2, there is a difference of h between them. Remember? But then the h, we will call it delta x. And over here, we have what? We have a f of x2 on the top, right? F of x2 on the top. And at this point, this will be what? F of x1, right? This point is f of x1. Everybody see that? This point is f of x1, right? So instead of f of x2 minus f of x1, you know, instead of delta y, we just say f of x2 minus f of x1, right? So f of x2 minus f of x1 will give us what? Divided by what? Divided by x2 minus x1. x2 minus x1 will give us what? The tangent of this angle, right? Correct?
Yes.
The opposite divided by the adjacent. It's the tangent, right? This is the same thing that we have been using different notation, right? We've been using different notation. We said delta y divided by delta x is equal to what? Change in y
and
divided by change in x, right?
Right.
Change in y divided by change in x. So we're expressing it this way. So this is similar to this one. Okay? Everybody is following?
Yes.
Okay, good. Then let's keep going. We're going to go to the next. Now what we're going to be doing is we're going to be watching, okay, L and P, and we're going to be monitoring them. So this is a circle, and this is the normal. You know the normal, right? The normal is what? The radius that's perpendicular to what? The tangent. It's called normal from now on, okay? Now we will see the relationship. This is the origin, okay? So L is tangent to the circle at P. The line L is tangent to the circle at P. When a line touches a circle, it will touch the circle at just one single point. If it's more than one point it's touching, that means what? The line is getting inside the circle, right? Shabab.
Yes.
If the line is touching the circle in 2 points or more, that means the line is getting inside. We don't want the line to get inside. We just want the line to be what? Touching one point. Like assume this is a ball, right? A ball that you play football with, and you put a ruler here. That's like the tangent. Okay? Everybody? Shabab?
Yes.
Everybody? So if we draw the radius, if we draw it perpendicular to the tangent, this is called the normal. Okay? So L is tangent to the circle at P. If it passes through P, perpendicular to the radius OP. This is the radius OP. Okay? Clear? Shabab, clear or not?
Yep.
Good. Let's now take a look at some motions. And I think we did this one, right? This is where Q is, and this is where P is. So we're introducing Q. What we want to do is we want to move Q on this curve, and we take this Q all the way until Q becomes where? As close to P as possible, and until Q goes into P. This is just like if you consider the distance between these two as h, remember? Remember when we use h equal to 1, think of the distance between the two as 1. And then we reduce it to 0.1, and then we reduce it to 0.101, and then 0.001, right? So assume that this point Q is moving along the trajectory of the curve. Okay, so it's moving along this one. What will happen to the tangent? What will happen to the tangent? The tangent is the red line. See the red line? See the red line?
Yes. Yes.
Okay. If we want this point P, okay, and this point Q to getting close to each other, let me explain it on this one. This one has enough spread. This one are tied together. Let's take a look at this enough spread. Assume that Q is moving towards this. So we have the secant. Where is the secant? It's this black line. This is a secant, right? This is a secant. So if this line, we moved it over here, right? Where would Q be? If we move this line over here, where would Q be? Over here. This line became over here. Where would Q? Q will be here, right? Where it crosses, correct?
Correct.
Q will be at this point if we move this line like this. Assume this line where we just grab it from this point and move it until it become at this point. So you can see where is Q is a crossing. So Q will be right here, right? Shabab, معي ولا لا?
معك.
Okay, so Q will be here. Okay, now what if we also held this line and move it that way to this point? Where would Q be? Q will be here, right? Where the arrow, right?
Yes.
Right.
Okay, now assume that we held this one and moved it to this point. Where would Q be? Q be closer to P, but not quite P. Now, finally, we took it and moved it and brought it over here. Then what? This line will be tangent and Q will be what? Will be on P.
Same.
Yes, same as P. Very good. Right? So we can say approaching P from the right, this is what is going to happen. We shrink the distance between P and Q, approaching P from the right. Okay? What about this? Approaching P from where? From the left, right? This is approaching P from the left, right? Shabab,
Yes.
Q is to the left of P here. Q is to the right of P here, right? So this is approaching P from the left, from the right, and this is approaching P from the left, right? What has okay.
نعم.
So the tangent line to the curve at P is the line through P, whose slope is the limit of the secant line slope as Q goes to P, right? Remember when we put the equation, we said f of x plus h, let's say minus f of x, okay, over, let's say h, okay. This is just like saying what? H is just like saying Q minus P, okay? H is just like Q minus P, right? So we're talking about what? The secant line, the limit of the secant as Q reaches P. When Q reaches P is similar than when we're taking H smaller and smaller and smaller, right? Remember, reducing H. H is just equals to what here? H is equal to Q minus P. Okay? H is equal to Q minus P. So when Q gets closer to P, H gets smaller. Right? So what they're telling us here is that the tangent line of the curve at P is a line through P, whose slope is the limit of the secant, right? Limit of the secant line slope as Q goes to what? P. Okay? I want you to remember this statement. Okay? One more time, I'm going to read it. The tangent line to the curve at P is the line through P whose slope is the limit of the secant. Remember, it is slope. So we're talking about the slope of what? The secant, the tangent. Okay? The slope is the limit of the secant line slope as Q move from its position to P. Okay, from either side, either from the right or from the left. Let's go back to the circle. Okay, we want to see the one that has a secant. So let's see, here is the circle that has a secant. Tell me what the tangent, I want to of this. Right?
الواي على الإكس.
Yes, delta y على delta x. Delta y divided by delta x. Okay? Now, remember when I asked at the beginning of the class and somebody answered, he said rate of change, right? So this is the rate of change. So delta y over delta x literally equals to what? Equals to f of x2 minus f of x1 over x2 minus x1, right? Where x2 minus x1 is h, right?
Yes.
Okay, so now we're going to, okay, of what? Of this, okay? Let's rewrite this one. This is f of x1 plus h minus f of x1, right? Divided by x2 minus x1 plus h minus f of x1 divided by h is going to give us what? Remember, we said the slope. The slope. Remember, I told you, remember this statement? It gives us the slope. It will also give us the derivative. Remember, ya Shabab, we did that? It gives us the derivative. Now, we know that f of x is equal to what? X squared, right? So we'll say the limit as h goes to 0 of what? F of x plus h will be what? X plus h, all what? Square, right?
Square.
F of whatever is equal to square of that thing, right? This is minus what? F of x will give us what? X squared.
Square.
Divided by h, right? This will be equals to limit as h goes to 0, and then I will have what? X squared plus 2xh minus x squared, right? Divided by what? H, correct? We take x squared out, right? If we take x squared out, this is gone, right? What are we left with? 2xh divided by h, right? We just get rid of x, h. We have 2x. So limit as x goes to 0. I'm not worried because I eliminated what? The denominator, right? I eliminated the denominator. Now I'm saying, let's take h equals 0. What do we get? We get 2x. 2x is what? Is a derivative, right? Derivative of fx. You got it?
Yes.
Okay. So let's go back to that statement, and I am sure after this you will understand what that statement means. Okay. The statement says what? It says the tangent line to the curve at the point P is the line through the point P whose slope, the slope of the line, is the limit of the secant, okay, as Q goes to P, which is like as H goes to 0. Is that clear, Shabab?
Yes.
Everybody? Very good. Okay. Now we will go ahead and get into limits of functions. Okay. Let's take a look at this function, f of x equal to h squared minus 1 over x minus 1. What we're going to do is just going to plug in a value for x. Let's start with x equal to 0.9. X equal to 0.9, this will give me what? 0.81, right? Minus 1 divided what? By what? 0.9 minus 1, right? Just plugging. What are we going to get from the top? I'm going to get 0.19, right? From the bottom, I'm going to get 0.1. 0.19 over 0.1 will give me 1.9. Isn't that this value? Huh?
Yes.
Good.
Same.
So if I plugged in this value, it will get me what? It will get me 2.1. And if I continue, what do you think is happening? I'm approaching what? 1 on the side, right? And I'm approaching what? 2 in this side, right?
Right.
So we can say limit as what? X approaching what? Tell me, X is approaching what? X is approaching
0.
no.
To 1. To 1.
So we can say limit as h approaches 1. Limit as h approaches 1 of what? F of x, right? F of x will be approaching what? When x approach 1, f of x will approach what?
2.
2, right? Limit of h, limit of f of x as x approach 1 is equal to 2. We just proved it here, right? We proved it here, correct? Shabab?
Yes.
Everybody? Everybody is comfortable?
Yep.
Good. Let me go ahead and go to the same and prove this using algebra. Let's take a look. What do we have in the numerator? We have x squared, right? minus 1 divided by x minus 1. So let me just go ahead and put that as x minus 1 multiplied by x plus 1, okay? And that's divided by what? X minus 1.
This one.
Correct? So I can just go ahead and do what? Get rid of
Delete.
x minus 1 with what? X minus 1, right? Since I got rid of the x minus 1, I can now plug x equal to 1. Before I cannot plug x equal to 1, why? Because if I put x equal to 1, I will be in trouble. Yes. So if I use algebra, I just eliminate the numerator. I eliminated the numerator. Now what do I have? X plus 1. So I can plug for x1. It will be 1 plus 1. So 1 plus 1 is equal to what? To 2. So that proves that limit of f of x as h goes to 1 or x as x goes to 1 is equal to 2. Right? We proved it using algebra. Clear?
Clear.
Good. Let's get going then. Here is some mathematics with the functions. So you can say that we just said that limit as x goes to 1, f of x, and we said the limit is equal to 2, right? So just symbolically, instead of using numbers, we're saying limit as x goes to h of f of x equal to L. Okay? Assume that limit of f of x as x goes to c equal to L. Also assume that limit another function g of x as x goes to c, assume that the limit is equal to m. Then the sum rule. The sum rule means what? The limit of the sum of two functions equal to the sum of the limits of each function. That means the limit is linear. One more time. The limit of the sum of two functions equal to the sum of the limits of the two functions, right? مفهوم يا شباب?
Yes.
Is this clear?
مفهوم.
Now, the limit of the difference of two functions equal to the difference of the limits. Okay? And if we multiply a function by constant and get the limit of the result of multiplication equal to the multiplication of the constant to the limit. That means what? If I want the limit of this, I will just say equals to k because k is constant. And then I will put limit of what? F of x, right? As what? X goes to c. And that will give me what? K. And then I know limit f of x as x goes to c. They told me that's equal to what? Equal to L. So I'm just going to multiply that by L. Correct?
Yes. Okay.
Good. So we can also look at the product. Limit of the product of two functions equal to the product of the limits. Okay? Limit of the product of two functions equal to the product of the limit. Limit of the quotient of two functions equal to the quotient of their limits, assuming that the limit is not going to be 0. All the time, anytime, if we're dividing anything, the denominator must not be equal to 0. This is the condition. Okay? There's no condition up there. This is the only time that we have a condition here because we're dividing. So we make sure that the denominator should not be equal to 0. Okay? And then we have what? Limit of the exponent, right? So this is f of x raised to a power n. Equal to what? Equal to the exponent of the limit, right? Limit of the exponent of a function equal to the exponent of the limit, right? Also, we assume what? N to be positive, okay? Integer. And limit of the radical, here the nth root, limit of the nth root of a function equals the nth root of the limit of the function. Correct, ya shabab? If n is even, we just have to assume that f of x greater or equal to 0 for x in an interval containing c. That's the only assumption that we have to have. Clear, ya shabab? Would you like
Can we take some examples,
a
teacher?
break? Would you like to take a break?
Yes, Dr.
Okay.
Yes,
Okay.
yes.
Okay. Let's take break, rest the brain a little bit, and then let's get back. Okay. We'll get back at about what? In 10 minutes?
10 minutes.
10 or less, please.
Yeah.
Not more. Okay. Have fun. We'll see you after 10 minutes.